Good evening, everyone. So my name is Larry Luo. So I'm a software architect at IBM. So today I'm going to talk about IBM contributions to the ClickHouse community. And also I'm going to talk a little bit about the one of the feature our team is working on. It's called support Kusto Query Language in ClickHouse. Just quickly give you guys an overview how IBM uses ClickHouse. So ClickHouse is a key component in both Instana and QRadar. So both Instana and QRadar are very important IBM product. So IBM today has hundreds of ClickHouse servers deployed, and the number is growing. So we made considerable amount of contributions to ClickHouse code base. I'm just going to quickly go over some of the important ones. A lot of our contributions are aiming to enhance security standards in ClickHouse. So we address CVEs. So whenever there's CVEs discovered, we actively working on try to get it resolved. Of course, we fix the bugs and improve performance. We routinely apply static analysis and code audit just to make sure the ClickHouse code base meet the highest standard. Highest security standard. Some of the security-related features we contribute, like, for example, salt password hash is one of our contribution. So here's the PR, and also FIPS compliant is a major contribution from IBM. So FIPS compliant requires ClickHouse to dynamically link to FIPS validated open SSL. So it need to do that during the runtime. So our team contribute to the ClickHouse to allow ClickHouse to build in the way you can dynamically load open SSL. Which is provided by operating system. So this is, so our contribution to make sure the ClickHouse can run in FIPS compliant mode. So we also contribute some other features. There's some like a brief instruction. For example, we have this structured logging support. By default, you see the ClickHouse log in a tag format. So now we introduce this JSON format. When you enable it, you can create you can capture ClickHouse log in a nice JSON format for your further analysis or some other work, right? And the second one is some capability to ignore indexes. So those are the recent our recent contributions. Of course, we work on porting ClickHouse to support other platforms. Power Platform and S390 are the two platform we are currently working on to make sure ClickHouse can run on this platform properly. And the last is the invert index, support invert index in ClickHouse. So this is a major contribution from our team. So the originally ClickHouse doesn't have this invert index support. So by supporting invert index, gave ClickHouse ability to do better when in like a full text search context. So this is our major contribution. It's well received by the community. A lot of people interested in this feature. We received a lot of feedbacks. Next, I'm going to talk about a feature our team is working on currently. So we're working on supporting Kusto Query Language in ClickHouse. So before I go into the detail of Kusto Query Language, so let me just use a test case to show the motivation. So for example, if I have this a table containing sales figures, it has shipping cost, profit, sales, and also have some geographic information, province, and have a product information, product category, product name. So this is a table containing sales figures, right? A business person, they could ask some questions about this data. Like a typical question could be like this, what are the top 2 province or regions by sales, and also the total sales of other province? You take that top 2 and total all the other province. And also the question could be, another question at the same time could be, what are the top 2 product categories in each of the 2 province, in each of the top 2 province, right? The third question is, what are the top 2 products in each of the product category? You see, this is like a hierarchical question. To answer this question, you need to create this data. You see, this data is hierarchical data, hierarchical result. So I'm just going to present the result here. You see, from the test data I have, British Columbia is the British Columbia and Ontario are the top 2 provinces. Within each province, let's say in British Columbia, in BC, the top 2 product category are office supplies and technology. Under office supplies, the top 2 product by shipping cost is, this cubic foot compact freezer and a filter. After this 2 product, there's a summary for all the rest product, and here is summary for the rest of the product category. So you see, this is a hierarchical data set, data result to answer this business question. I assume a lot of you guys are working on ClickHouse, or probably you guys are expert of SQL as well. So now I'm going to show you the difference, show you the 2 queries. So this side is the SQL, and this side is the Kusto Query Language. So the purpose is not ask you guys to read this SQL, just to see the size, how many lines. To create the result I just showed, you need to write what I need to write, a SQL with like 2 pages. And I'm pretty sure I made hundreds mistakes while I'm writing the whole things. Just type this whole thing. It will take me 15 minutes at least without thinking if I can remember everything. So this is the SQL. In comparison, you see this side. This is the Kusto Query Language. Does exactly the same thing. Maybe I'll just quickly introduce, do an introduction about the Kusto Query Language, right? So Kusto Query Language is an open source query language specification. Is created by Microsoft. So this is open, but this is the open source spec. So Kusto Query Language uses a data flow mode. It's very easy to read write and automate, right? So the Kusto Query Language is like this, typically like this. You have a data source, and you have a pipe to operator, and this is like a Linux command. So you have a data source, you pipe to an operator, create a new data, you pipe to another one. You can do this, continue on and on forever, right? So does that answer your question? It's not easy to make it right. You do a lot of lot of work to make that query correct. So in this slide, I'm just trying to give you guys an idea how easy compared to SQL, how easy you can create this data with Kusto Query Language, right? So basically here I just have a table name, then there's top nested is a Kusto operator. I have 3 of them, then I'm done, right? So yeah, so this just an introduction of a Kusto Query Language, right? So the each of this operator create a data as a data source for the next operator. So when you're working on these operators, actually they are kind of independent. You work on one, you don't need to really consider how the previous one works. This is make it very easy. If someone gave me a query, I need to do some further processing, so I can just continually doing this. But if you do that in SQL, you have to modify the original one if you add the things, right? Things get very complicated. So yeah, so this is just show the motivation why Kusto Query Language is appealing to us for I guess to all the ClickHouse users. Okay, so here just shows how we incorporate Kusto Query Language into ClickHouse. So what we did is we have this dialect control. We introduced a new dialect in ClickHouse. Like by default, ClickHouse has a ClickHouse SQL is a ClickHouse dialect, right? So we introduce a new Kusto Query Language dialect. You can set a dialect to Kusto Query Language. Then your query will be sent to a new KQL parser. So there's equivalent to the SQL parser in ClickHouse today, but it's sent to the KQL parser, which is contributed by our team. What the KQL parser does is it's convert the KQL into a valid SQL AST. It's like this. So you see this green part is the new thing, and all the rest are the existing ClickHouse features. So the benefit of this is ClickHouse has query analyzer, query optimizers. So our solution will take advantage of the query analyzer, query optimizer automatically. So if there's some new improvement in ClickHouse query analyzer, query optimizer, it will automatically improve the KQL solution we introduced. Also, yes, we added. It also keeps our KQL translation simple, so we don't really need to go to a lot of optimizations. We can just take advantage of the query optimization in ClickHouse. So this is shows how we incorporate Kusto Query Language into ClickHouse. So the next slide is just some details. How do we translate KQL into ClickHouse SQL? I'm not going to walk through all of this in detail, but basically it does recursively walk all the KQL operators one by one and generate subqueries and chaining them together. At the end, you have a valid SQL query. Okay, so we created this demo program to show the query transformation. So we're not going to run the query against the data, but you just get a number. So here we're just going to highlight how the KQL query got translated into a valid SQL query. So I'm just going to run some example I have here. Let's start from simple one, right? Right. Okay. Let's start with some simple ones. So basically, this one is just from a customer is a table. Customers is a table, right? We just run a summary on the customer table with get schema. Get schema is just to show the data structure of the query result. So this is the equivalent SQL this KQL query translate to. So if I run this, this is a valid SQL or ClickHouse SQL query. Right. So this is a simple example. Okay, so this is a query use filter, where is equivalent to filter, and summarize. Summarize is equivalent to SQL group by kind of thing. If I run this, so this is the equivalent SQL. You see there's a subquery and outer query consume the result of this subquery. So this is how this pipe got translated. They translated into subquery. Well, let's just go directly to the one we were talking about before. This query answers like 3 business questions in one shot. Okay, so this is the KQL query, answer the business question I showed before, top 2 province and the top 2 product category, top 2 province by total sales, top 2 product category by average profile, profit within province, within the top 2 province, and then top 2 product name by average shipping cost within this category. So this is the KQL query answer that question. So if I run this, if I translate this into equivalent SQL, yeah, it's very long. So I mean, I wouldn't want to type this SQL. I want to use this all the time. Especially if I need to automate something, write a program to change the parameter in this. It's much easier to walk through the SQL template or to do fancy things. Yeah. Okay. Yeah. So that concludes my presentation. Is there any questions?